In this question, we have a horizontal projectile. A toy car is launched from a table with a velocity in the x direction of 3.6 meters per second. The toy car will fall to the ground, which is 1.3 meters away. Our job in this question is to figure out how far it goes before hitting the ground. We'll label that with the letter X right here. We'll need to figure out the time it takes for it to get to the floor in order to figure that out. Remember, we must keep X and Y completely separate. What do we know in the X direction? Well, we know it is constant velocity. Therefore, the only useful equation is d equals vt. Let's fill in what we know. Displacement, we do not know. Time, we do not know. But we do know the velocity. That equals 3.6 meters per second, as listed in our diagram here. Now, all the way down, it'll be 3.6 meters per second in the x direction. Now, what do we know in the y direction? We'll place that over here. In the y direction, since we're giving a push only in the x direction, our beginning velocity, v1, will equal 0 meters per second. We do not know the velocity 2. Acceleration is gravity, negative 9.8 meters per second squared. Displacement will be negative 1.3 meters. We once again place the origin where the object starts moving. It'll fall down 1.3 meters before reaching the ground. Since we're below the origin, it'll be minus 1.3 meters. And we do not know time. That is a question mark. Remember, we're trying to find how far this object goes in the x direction on the way down. And x marks the approximate spot where it will hit. We don't need velocity 2 in order to find time, so we choose our velocity 2 independent equation. That would be displacement equals v1t plus 1/2 at squared. We will now put in the information we know and solve for time. Negative 1.3 is equal to, this term becomes 0 because our beginning velocity is 0, plus 1/2 negative 9.8 t squared. We have a simple quadratic to solve for, and our time turns out to equal 0.52 seconds. We can record that here. We can also record that in our chart. T is 0.52 seconds. And we can record that in the x direction because time is the same for both, 0.52 seconds. Now we have enough information to use our displacement equals velocity times time equation in the x direction in order to solve for the distance it goes in the x direction on the way down. D will equal 3.6 multiplied by 0.52. That'll equal 1.9 meters. The second part of this question is, what about the velocity vector just before the car hits the ground? We'll draw it as a triangle. All vectors can be written as a triangle. The direction would be downwards along some kind of a hypotenuse here. We'll call that V sub r. V sub r will be comprised of a velocity in the x direction and a velocity in the y direction. Angle theta will be relative to the horizontal. So how do we get this information? Well, all the way down in the x direction, the velocity is equal to 3.6 meters per second. We can record that right now for the velocity in the x direction. We then go back to the y direction and refill in our chart, and this time we'll solve for velocity 2. So here's our y direction chart. v1 is equal to 0. We do not know velocity 2, and this time we will solve for that one. Acceleration is still negative 9.8 meters per second squared. Displacement, negative 1.3 meters. Time equals 0.52 seconds. we can choose the equation velocity 2 equals velocity 1 plus AT in order to find velocity 2 in the y direction, which again is the instant just before the car hits the floor. Velocity 2 is going to equal 0 plus a negative 9.8 multiplied by 0.52. Solving for velocity 2, we will get 5.1 meters per second, and it will be negative. We record that over here. Notice how the vector is pointing downwards, indicating that it is negative. So 5.1 meters per second. Now we have our Vx and our Vy. We will need to Pythagorize in order to get the hypotenuse, and then invoke the inverse tangent function to find the angle. Therefore, V sub r is equal to the square root 3.6 squared plus 5.1 squared. V sub r is equal to 6.2 meters per second. The tangent of theta will then equal our Vy over our Vx, so it's 5.1 divided by 3.6. Now we want to know what angle this ratio is true for, so we must take the inverse tangent of this ratio. The angle theta is equal to 55 degrees. Now we will reference that as below the horizontal. You're used to referencing things in terms of north, south, east, and west. But this is a vertical question where we have up and down. So here's our horizontal. Our angle swings this way at 55 degrees. So you can see we are below the horizontal. Our VR, which is the hypotenuse of this triangle, is our 6.2 meters per second.